on it is my contact. So this week on Yaaka, we are offering free online learning for classes from P1 to Senior 6. So we welcome you and we hope you are going to enjoy our services. So let us begin our lesson. So today we are going to look at the statistics of a particle, and we said this is a part of mechanics that deals with particles that are not in motion. So when those particles are not in motion, so we don't expect any acceleration to act on those particles. So their net resultant force is 0. So they don't have any force, any net force, the resultant force that causes those particles to move. So it doesn't exist. So our resultant force will always be equal to 0. So we are saying we can solve problems involving particles in equilibrium by considering forces acting horizontally and vertically. So we shall have our forces in the vertical and on the horizontal. So on the horizontal it is x-axis, and on the vertical it is y-axis. So our major procedures is to begin by drawing a diagram and labeling all the forces. Then we resolve into horizontal and vertical for forces not on an inclined plane. Then when we have forces on an inclined plane, we resolve perpendicular and parallel to the plane. Then we set the sums equal to 0, because we said these objects are in equilibrium, and that means they are not moving. So the forces acting in opposite directions must cancel out, or mathematically we say they are equal. Then we solve the equations to find the unknowns. So for example, if we consider this system of forces where we have forces of P, 4 and Q, and the P is at an angle of 30 degrees, the 4 is at an angle of 45 degrees. So that means we are going to resolve this into the vertical and the horizontal. So for each of the forces, but this Q is vertical, is on the vertical, so it doesn't have a horizontal component. So we are going to only deal with P and 4 newtons. So let us begin. Those who have their videos on, can we turn them off? So we're saying the particle to be left in equilibrium, we calculate the magnitude of the forces P and Q. So we're saying this means the horizontal and vertical forces cancel out, and we are saying in brackets acceleration is equal to 0 in both directions. So the resultant force is also equal to 0. So when we begin with the P Newton force, it's vertical and horizontal. So the horizontal is on the x-axis and the vertical is the one on y-axis. So when we go back and borrow some knowledge of trigonometry, we know that sine of an angle is equal to opposite divided by hypotenuse. So here, when we get sine of 30, it will be equal to Maybe if we call this one x and this one y. So sine of 30, opposite is y. Then we divide this by the hypotenuse, which is p. So when we multiply the p both sides, our y would be p sine of 30. So when we do the same, the horizontal will be p cos 30 because this is adjacent, and the opposite will be p sine of 30. That is for the p. Then we get back to the 4 Newton force. So it will also have a horizontal component and a vertical component. So when we still use the trigonometry, it will give us, so this adjacent, which is along the horizontal, will be 4 cos of 45, and the vertical will be 4 sine 45. So that is, we have now found the horizontal and vertical components of each force. I said the Q Newton force is only along the vertical, so it doesn't have a horizontal force. Then we begin now resolving. So we begin resolving horizontally. And we are going to use F is equal to MA, which is from the second Newton's law of motion. F is the resultant force, M is the mass of the body or a particle, and A is the acceleration. And remember here we said our acceleration is equal to 0 because the forces are in equilibrium. So we are going to begin by choosing a direction as positive, and then we substitute in the values. So along the horizontal, we have P cos 30 and 4 cos of 45. So by choosing the positive, so the positive, we are going to begin with the P cos of 30, and then we subtract the 4 cos of 45. When we rearrange and take the 4 cos 45 to the right hand side, it becomes positive, and P cos of 30 is equal to 4 cos of 45. When we divide by cos of 30 on both sides, we shall have P is equal to 4 cos 45 divided by cos of 30. And when we substitute in a calculator, we shall get P equaling 3.27 newtons. Is this step okay?
Yes, sir.
Okay. So we can proceed?
Yes.
Okay, thank you. Now we have found the value of P. So we are going to resolve now vertically. So when we resolve vertically, so the positive side of y is on the upper side. So we are going to begin by adding these ones that are going up. Okay?
Yes.
And after adding, we subtract the q and equate to 0. So choosing direction, we choose the positive, which is 4 sine 45 plus p sine of 30 minus q is equal to 0. Okay?
Yes.
Then what do we do next?
Since we have the value for P, we just substitute it.
We just substitute for the value of P.
Yes.
Okay.
And also take Q the other side.
Okay, we can take Q the other side, like what I have here. And then after that, we substitute the value of P.
Yes.
Okay.
Yes, sir.
And we substitute in a calculator and we get Q as 4.46. And in paper 2, when you are in the exam, you don't need to give a lot of steps. Okay.
Yes.
And because you have a scientific calculator. So we get a value of P as that. So we are having a small note here that you will usually need to identify which direction is solvable first. And then you substitute and in the other one, like what we have done. So this is one of the examples. So we can proceed to another example. So I'm saying in the second example, who can read for us? Who can read for us? Let me read and we continue. So we're saying you can solve problems involving particles in equilibrium by considering forces acting horizontally and vertically. So we're saying the diagram on the right shows a particle in equilibrium under a number of forces. Calculate the magnitudes of the forces P and Q. So that is our diagram. So it is not very much different from what we have seen in the first place. So here we are going to be a little bit faster. So we start by resolving in both directions, the vertical. So we shall have one adjacent for P. So we shall have P cos of 40 and the opposite P sine of 40. Then we come to the Q. It will be the horizontal will be Q cos of 45 and the other one will be Q sine of 55. And then now we begin resolving. So who can tell us the first step? First step, what are we doing?
We calculate for the horizontally.
Horizontal. But we said we begin by choosing direction, okay?
Yes.
Which is the positive. So we are going to get P cos 40 minus Q sine 55. No, minus P cos 55. And
Yes.
we write that equation on this left-hand side because now we are going to have two equations. Then we resolve vertically. Choosing direction is positive direction. So we are going to get this plus this that are moving down upwards, and then we subtract the 2 Newton force.
Yes.
So that will give us P sine 40 plus Q sine 55 plus 1 minus 2. There is this one here. It is also moving upwards, okay?
Yes.
Minus 2 that is going downwards, and we equate that to 0. So it also becomes P sine 40 plus Q sine 55 minus 1 is equal to 0. So it also becomes our equation what? Equation 2. So from equation 1, we are going to make one of them the subject, okay? So
Yes.
P, if we made P the subject, it would be equal to Q. So we first of all take this one, this other side, and it becomes positive. Isn't it so?
Yes.
Because when it changes, when it crosses equal signs, it becomes positive.
Positive.
Then we divide by cos of of 30,
40.
of 40. So that gives us P is equal to Q cos of 55 divided by cos of 40. So after that, we are going to substitute the P in equation 2. So in equation 2, when we substitute, replace P with the Q equivalent. So that will give us, so where there is P, okay? So we are substituting where there is P, we are substituting the whole of this value to give us Q cos of 55 divided by cos of 40, sine of 40, plus this minus 1 is equal to 0. Yes. So after that, we multiply all those terms by cos of 40, because for it is in the fraction. And that will give us Q cos 55 sine 40. When we multiply it here, it will give us Q sine 55 cos 40. When we multiply it by 1, it will give us negative cos 40 and is equal to 0. So after that, we add the cos 40. So it crosses to the equal sign to the other side after the equal signs, and it becomes positive. And then on the right hand side, we see that the Q is a common factor. Okay. So we have to factorize it out. And after factorizing it out, we are going to divide by the bracket. So we divide by this or these two sides. Okay. And after dividing, when you substitute in a calculator, our value will be 0.769 newtons. Any questions before I proceed?
We had the 2 Newton before, but I'm not seeing it. I'm sorry.
The 2.
Yes.
I remember it was 1 minus 2, wasn't it?
Oh,
Yes.
yes. Okay. Yeah.
It was this. So 1 minus 2 will give us a negative 1.
Yes.
Okay.
Yes.
Any other?
No.
Okay, so we can proceed. So after, to get the value, can the one having that music first mute their microphone? Dote, can you unmute your microphone? So let's continue. So when we come back, what we are going to do now, we are going to get back and substitute for Q in this equation here, because we now have the value of P, of Q. So that means when we substitute, we shall have P is equal to 0.769. Please, members, I requested that you unmute your microphones.
Yes, sir.
Okay, so we can proceed.
Yes.
So we are saying we are going to, since we obtained the value of Q, we are going to substitute it in this equation here, which was P is equal to Q cos of 55 divided by cos of 40. So when we do that, it will lead us to this equation here, where we have 0.769 cos of 55 divided by cos of 40. And when we substitute in the calculator, that will give us 0.576 newtons.
Yes.
Okay. Then we now go to a situation where we have one that is inclined on, or inclined at a certain angle to the horizontal. So this one is inclined at an angle of 30 degrees. Okay.
Yes.
So, and it is acted upon by this 5 Newton, the 2 Newton, and the P Newton. The P Newton is acting at an angle theta to the incline, okay? Acting
Yes.
at an angle theta to the incline. So likewise here, we are going to begin by resolving, okay?
Yes.
Yes.
So if we begin by resolving P, so this side is the opposite. This down one here is adjacent. So the adjacent is P cos theta. This opposite will be P sine of theta. Then we go to the 5 Newton force. So there is an angle there. And that angle, for some of you have studied some trigonometry, is equal to this angle here. Okay? Those two angles are what? Are equal. So this becomes the opposite, and this one here is adjacent. So the adjacent is 5 cos, and the opposite is 5 sine 30. Then the 2 Newton forces, that one is perpendicular to the plane, so it doesn't have a horizontal component, since it is vertical to the what? To the plane. So after that, we begin by resolving parallel to the plane. So the parallel, we mean those forces that are parallel to the plane, okay? Which act like in the same direction as this plane here. So in those, we have this, and I think those are the only ones. So the direction, this one here going upwards, we take it to be positive, and the one going downwards, we take it to be negative. Okay?
Yes.
So we shall say P cos of, what is the 8? Okay. We have this 8 Newton force which has come up, so I think it was also there. Here, okay? So for it is acting downwards. Okay? So we get the P cos of theta minus these two, because for them they are acting downwards, okay? Sloping down the plane, whereas this one is acting upward, the plane. So P cos theta minus 5 sine 30 minus 8 is equal to 0. So when we rearrange, the negatives are taken to the right hand side, and P cos of 30 is equal to 5 sine 30 plus 8. And then we write it this side as our first equation, and then we again resolve perpendicular to the plane. So perpendicular to the plane, is where we have those forces, a P sine 30, a 2 Newton, and a 5 cos 30. So these ones acting this way are regarded to be positive, and these ones here are regarded to be negative. So what we do, we begin with the positive ones. P sine of 30 plus 2 minus 5 cos 30 gives us a what? A 0. So when we rearrange, P sine 30 gives us 5 cos 30 minus 2. So we take it to be equation 1, to be our equation 2. So when we get back to trigonometry, when we get sine divided by cos, what does it give us? Sine divided by cos,
Tan.
it gives
Tan.
us tan. Okay.
Yes. Yes.
And tan is easier to do what? To solve.
Oh.
So we are going to get equation 2 divided by equation 1. Okay. So the P will cancel out, and it gives us a tan. Then we get 5 sine 30 minus 2 divided by 5 cos 30 minus 2. And when we work that out in a calculator, tan of theta is equal to 0.2219. And when we take the tan inverse, theta will be equal to 12.5 degrees. So after getting the angle, we can now easily substitute it in and get the value of what?
P.
Yes. So when we use P cos theta equaling 5 sine 30 plus 8, that will give us P is equal to 5 sine 30 plus 8 divided by cos theta, and that will be 5 sine 30 plus 8 divided by cos of 12.5, and that will give us 10.8 newtons. Is that clear?
Yes.
Okay. So we can proceed. So we are also given a particle here that is acted upon by Q, P, and 3 newtons. And the Q is acting at an angle of 45 degrees. So we shall, as usual, so since this one can be converted into vertical and horizontal components, so we get the vertical component and the horizontal component. So the horizontal will be P Q cos of 45, since it is on the adjacent, and the opposite one will be Q sine of 45. Then this other one, this one is only along the horizontal, so it doesn't have a vertical component. This one is in the vertical, it doesn't have a horizontal component. Yes. So resolving vertically, this is the positive, this will be in the negative. So that will be Q sine 45 minus 3G. And here we take it the other side, so Q is Q sine 45 is equal to 3G. The Q is equal to 3G divided by sine 45. After dividing sine 45 both sides, So when we calculate, the G is acceleration due to gravity, and it is always given on the question paper. So when we calculate, our answer will be 4.1.6 newtons. Is that okay?
Yes.
Okay, so we can continue. So this is what that is what I had prepared for today, unless there are some questions directed to me. Are there some questions? Okay, if there are no questions, let me briefly talk about our services here. So at Yaaka, we have services. Apart from these free lessons we are running, we have online classes which go up to 500,000 Ugandan shillings. So this includes teacher-student interaction by holding class engagements, like what we have had. Then access to courses, subjects on the Yaaka website, which is yaaka.cc. So there are assignments there, there are quizzes there that students do, and we as teachers mark them. And after that, after doing all that in a single class, you are promoted to the next class. Then when you go to the part of downloads, a single subject is 10,000. All subjects per primary class is 30,000, and all subjects per class in secondary is 50,000. And you have access Yaaka through that HPTC but just if you put in yaaka.cc, it will bring it. Then also have Educare, which is on this right hand. So membership, we have membership levels. So it gives you a 2-day free access to interact with what is there. So the platinum, the bronze level is 20,000 per month. So that is if you're on a monthly basis. We have silver level, which is quarterly. So you divide the year into 4. So for every 3 months, you pay 50,000. Then we have gold, which is half a year. That is 6 months. That one you pay 70,000. Then annually, which is yearly, you pay 100,000. So this only includes access to the content. So you don't have live classes engaged in it. So that is what we offer at Yaaka. And if you feel very motivated, if our services are very good, I would request you to subscribe so that we could have more of these interactions. Otherwise, thank you very much for being interactive, for listening, and for your active participation. Thank you.
Thank you,
You're
sir.
welcome.
Thank you.
You're welcome, sir.
You're welcome.
Pia hiyo ni pia mali.